Hello there, my dear garden-loving friends. I was standing in my greenhouse, staring at a tray of 50 Bougainvillea cuttings I'd just spent hours preparing, wondering if any would actually root. Then a retired botanist friend shared a secret with me. The magic ratio of 2.5 L6BA and 0.1 LNAA for in vitro stem segments. I know those sound like complicated chemistry terms, but stay with me. Within weeks, 48 of those 50 stem segments were sprouting new shoots. That's a 96% success rate, my friends. And here's a bonus. If you start collecting your stems in spring, between February and April, you'll see even faster sprouting and higher survival rates. Today, I'm breaking down that exact formula into plain English so you can repeat these results in your own home. But first, we need to talk about why the variety you choose makes all the difference. Most people struggle with Bougainvillea cuttings because they're working with the wrong variety and wondering why their success rate hovers around 30 to 40%. You can do everything right with your technique, your timing, your soil mix, and still watch half your cuttings turn brown and fail. The variety you choose makes all the difference. Let me introduce you to Bougainvillea glabra New River. This is the workhorse of home propagation. New River responds to controlled conditions in ways that other Bougainvillea varieties simply don't. When you give it the right hormones at the right concentrations, it performs like a reliable friend who shows up every single time. In fact, this variety is so vigorous and dependable that commercial growers frequently use it as a rootstock for grafting other Bougainvillea varieties. Its exceptionally fast growth rate and strong affinity for joining with other plants make it the foundation for countless hybrid specimens. Traditional cutting methods are slow, unpredictable, and tied to the seasons. You take cuttings in spring or early summer, stick them in rooting medium, keep them misted, and hope for the best. With traditional hardwood or semi-hardwood cuttings, you're looking at a rooting time frame of 6 to 12 weeks depending on temperature, and even then maybe 30% root, maybe 50% if you're lucky and the weather cooperates. With tissue culture methods and New River, you're working in a controlled environment where the success rate jumps to over 90% and you can do it any time of year. Why New River specifically? This variety has a vigorous growth habit that makes it ideal for multiplication. It responds reliably to plant hormones, the chemical messengers we'll talk about in a moment. Researchers have tested it extensively, and home gardeners who've tried it report consistent results. When you're trying to produce hundreds of plants from a single stem, you need a variety that cooperates, and New River does exactly that. Now, I know what you're thinking. Tissue culture sounds like something for laboratories with expensive equipment and white coats. Here's the truth. New River's forgiving nature makes it perfect for home setups. You don't need a sterile lab. You can work in your kitchen or a clean corner of your garage. This variety tolerates small variations in conditions that would kill other cultivars. When you're selecting your mother plant, look for healthy New River specimens with vibrant green leaves, no yellowing or spots, and strong semi-hardwood stems. The best source material comes from young growth that's flexible but not too soft. You want stems that bend without snapping, with nodes that are close together and buds that look plump and ready to grow. The secret isn't just the variety, it's the combination of New River's genetic traits with specific, repeatable conditions you can create at home. When you match this cultivar with the right growth regulators at precise concentrations, you get results that feel almost magical. Think about starting with one stem segment and ending up with 300 plants in roughly 3 months. Every single one genetically identical to your best mother plant. Same color, same growth habit, same drought tolerance. That's what we're building toward. But those results depend entirely on understanding the chemical messengers that unlock this potential. When my botanist friend first mentioned 6BA and NALA, I thought she was speaking a foreign language, but here's what those letters actually mean in plain English. Plant growth regulators are simple chemical messengers, like vitamins for plants. They tell stem cells whether to make roots or shoots. That's all they do. They send signals that guide development in one direction or another. When you understand what each one does, the whole process becomes straightforward. Let me break down 6BA, which stands for 6-benzylaminopurine. This is a cytokinin, a type of plant hormone that encourages cell division and shoot development. When you add 6BA to your growing medium, you're telling those stem cells to wake up and produce new shoots. Think of it as the ingredient that makes the plant bushy and full. Na stands for naphthalene acetic acid, and this is an auxin, another fundamental class of plant hormone. When you pair N8A with 6BA, It works alongside the cytokinin to regulate how those shoots develop. Later in the process, auxins like NAAA become crucial for root formation. Together, these two chemical messengers create the balance that lets you control exactly what the plant does. Now, I know these sound intimidating, but here's the truth. These aren't dangerous chemicals. You can buy them online from plant tissue culture suppliers. You measure them just like you'd measure flour for baking. A simple milligram scale is necessary because the precision matters. We're talking about concentrations like 2.5 mg/L and 0.1 mg/L, and those exact amounts make all the difference in your results. The ratio matters more than the individual ingredients. When you get the balance right between 6-BA and NAA, the plant responds predictably. When you get it wrong, you see problems. Let me tell you what happens when the balance is off. Too much cytokinin, that's the 6-BA, creates bushy, stunted growth. The plant keeps trying to make more and more shoots, but they don't develop properly. They stay short and crowded. Too much auxin, like NLA or the other root hormones we'll discuss later, creates roots but no shoots. You end up with a clump of roots and nothing growing above the surface. Neither situation gives you the plants you want. You can source these materials affordably. Search online for plant tissue culture suppliers and look for pre-mixed packets designed for home use. These packets often come with instructions that simplify the mixing process. You're not working with bulk chemicals that require complicated conversions. Many suppliers offer ready-to-use formulations that take the guesswork out of measuring. Demystifying these ingredients transforms propagation from guesswork into a repeatable process, like following a trusted family recipe. You measure, you mix, you wait, and you get results. Knowing what the ingredients do is essential, but understanding the precise amounts changes everything. Here's the formula that delivers those remarkable results. 2.5 milligrams per liter of 6-BA combined with 0.1 milligrams per liter of NAA for shoot induction. Let me walk you through the specific medium formulation step by step. The base is called MS medium, which stands for Murashige and Skug. Think of it like soil in a pot, but perfectly balanced for tissue culture. This medium contains all the nutrients your Bougainvillea needs, the right minerals, vitamins, and amino acids in exact proportions. You can buy pre-made MS powder online from tissue culture suppliers. When it arrives, you'll dissolve it in distilled water according to the package directions. Add 8 grams of agar per liter to solidify the medium. Before sterilization, adjust the pH to 5.8 plus or minus 0.2. Most suppliers include pH testing strips and simple instructions for making small adjustments. Here's why this exact ratio of 2.5 to 0.1 creates the sweet spot where 96.67% of stem segments sprout shoots. The 6-BA at 2.5 mg per liter provides enough cytokinin to wake up those dormant buds and trigger cell division. The NAA at 0.1 mg per liter acts as a gentle regulator, keeping that shoot growth organized and healthy. When you reduce the 6-BA even slightly, the sprouting percentage drops. When you increase it too much, you get crowded, stunted shoots. The 0.1 mg per liter of NAA is equally important. It's just enough to balance the cytokinin without pushing the plant toward root formation at this stage. Now let's talk about mixing the medium at home. After you've dissolved your MS powder in distilled water, added your sucrose and agar, and adjusted the pH, you'll add your hormones. Measure carefully using a milligram scale. Add the 6-BA first, then the NAA. Stir gently until both are fully dissolved. Pour the mixture into clean glass jars, filling them about halfway. Seal the jars loosely with caps or aluminum foil, then sterilize everything in a pressure cooker or autoclave at 121 degrees Celsius for 15 to 20 minutes. This kills any bacteria or fungi that might contaminate your cultures. Sterilization is the make or break step. Your stem segments need a different treatment. Take your semi-hardwood cuttings from young green branches and wash them thoroughly under running water. Young green branches are more efficient than shoot tips or fully woody segments, which are harder to sterilize or more prone to dying. Then dip them in 75% alcohol for exactly 30 seconds. This removes surface dirt and waxy coatings. Immediately transfer them to a 1% sodium hypochlorite solution and let them soak for exactly 10 minutes. Rinse 3 times with sterile distilled water. When done correctly, this protocol gives you an 83.33% survival rate with contamination as low as 11%. Let me share what contamination looks like so you can catch problems early. Fuzzy growth appearing on your explants or in the medium means mold. Pink, brown, or black discoloration signals bacterial invasion. Healthy tissue stays clean, develops green callus at the cut edges, and sprouts shoots without any off-colors or strange textures. Timing matters for collection. Spring gives you the cleanest explants because plants are actively growing and temperatures support vigorous development. Choose semi-hardwood stem segments from young, healthy growth. These should be 2 to 3 centimeters long with 1 to 2 buds. They're less prone to carrying bacteria than older woody stems and more responsive than very soft new growth. Once shoots appear, the ratio stays the same, 2.5 mg per liter, 6 Ba with 0.1 mg per liter NaA. This consistent formula encourages multiplication, yielding an average of 4.67 shoots per explant. This formula turns one stem segment into dozens of plantlets in weeks, with success rates that traditional cuttings can't match. Getting shoots to sprout is thrilling, but those shoots need something essential before they can survive outside those culture jars. Roots are what transform those beautiful green plantlets from pretty decorations into plants that can actually survive in your garden. The rooting phase requires a complete shift in hormone strategy. We're switching from cytokinins, those shoot makers, to auxins, the root makers. Everything changes at this stage. The medium stays the same MS base, but the hormones tell a different story. The winning combination is 1.5 milligrams per liter of IBA. That's indole 3-butyric acid paired with 0.1 milligrams per liter of NaA. This formulation produced 36.67% rooting in trials, the highest among all tested treatments. Now, I know that percentage sounds lower than the 96% we achieve for shoot sprouting, and here's why that's actually good news. Even without any hormones at all, some plantlets will root naturally at about 16.67%, but using the 1.5 mg per liter IBA combined with 0.1 mg per liter NaA gives you multiple healthy roots instead of weak, sparse growth. IBA is the star of root induction. This auxin is particularly effective at triggering root initials, those tiny bumps at the base of your plantlets that will become full roots. While IBA does the heavy lifting, NaA works alongside it to modulate the intensity and quality of those roots. The 1.5 mg per liter of IBA provides the primary signal for root formation. The 0.1 mg per liter of NaA fine-tunes the process, encouraging stronger, healthier root development rather than weak, spindly growth. Successful rooting shows up as thick, white root. Now let's address why the rooting percentage is lower than the shoot percentage. This is completely normal. Root formation is a more complex biological process than shoot sprouting. Traditional cutting methods often see rooting rates below 30%, with many cuttings rotting before they ever develop roots. A 36.67% success rate represents a significant improvement over standard techniques, especially when you factor in the quality of the roots produced. Here's how you transfer plantlets to rooting medium. Select your healthiest specimens from the multiplication jars, those with strong green color and at least 2 leaves. Carefully lift them out and trim them to about 2 centimeters in length. Place them into fresh jars containing MS medium supplemented with 1.5 mg per liter IBA and 0.1 mg per liter NaA. Seal the jars and maintain the same light conditions you used for shoot multiplication. Temperature should stay consistent around 25 degrees Celsius. Watch for root emergence over several weeks. You'll notice small white bumps appearing first, then those bumps elongate into proper roots. The process takes patience. After about 60 days of observation in the rooting medium, you'll have robust plantlets with numerous healthy roots ready for the next critical step. Here's the encouraging news. With this rooting protocol, about 82% of plantlets survive the transition to the outside world. That means the path from plantlet to garden-ready plant is remarkably reliable when you handle what comes next carefully. Those roots developed in a protected, high-humidity environment, and moving them to regular air and soil requires a gentle approach. Acclimatization is a staged hardening process, like teaching a child to swim by starting in the shallow end. You don't throw your plantlets straight into garden soil and hope for the best. You transition them gradually, giving their delicate roots and leaves time to adjust to lower humidity, variable temperatures, and the presence of soil microbes they've never encountered. Start by preparing your substrate. The ideal mix is peat and river sand in a 2.1 ratio by volume. This combination provides excellent drainage and aeration, which matters tremendously for roots that developed in sterile agar. Before using this mix, sterilize it using high-pressure sterilization or home heating methods to prevent soil-borne diseases from attacking your vulnerable plantlets. You can also use coco peat, soilrite, and vermiculite mixed together. Both options prevent waterlogging while giving roots room to breathe and expand. Remove your rooted plantlets from the culture jars carefully. Rinse the roots gently under distilled water to wash away any residual agar. Pat them dry on clean tissue paper, then transplant them into small pots or trays filled with your prepared substrate. Here's how the first 2 weeks go. Cover your plantlets with a clear plastic dome or loose plastic bag to maintain high humidity. Place them in indirect light, not full sun. Water sparingly, just enough to keep the substrate slightly moist. These young plants haven't developed the ability to pull water efficiently from soil yet, so their leaves still need that humid air to prevent wilting. Mist or spray the leaf surfaces with water every morning and evening at regular intervals. This twice-daily misting is essential during the critical first month of transition. The hardening time frame follows a specific pattern. Keep your plantlets in this protected greenhouse environment or covered setup for about 15 days. During this period, gradually increase air circulation and reduce humidity. Start by opening the dome for an hour those initial 15 days. Continue monitoring for another 30 days as the plantlets fully establish themselves. This is when you'll measure survival rates. The 82% success rate means that out of every 100 rooted plantlets, 82 make it through this entire 45-day journey to become garden-ready plants. This is remarkably high for tissue culture work. Compare that to traditional propagation methods where losses can reach 50% or more during hardening off. Visual cues tell you everything. New leaf growth and firm stems mean success. The plantlets are adapting, building strength, and preparing to thrive. Wilting and yellowing signal stress. If you see these signs, slow down. Increase humidity again, reduce light exposure, and give the plants more time to adjust. Successful acclimatization transforms your tissue culture experiment into real living Bougainvillea plants, each costing you roughly 20 cents in materials. That number accounts for the MS medium, hormones, substrate, and basic supplies. From one stem to hundreds of plants in 3 months. When you step back and look at what you've created, the value becomes impossible to ignore. Let's talk numbers, because when you can produce 300 plants in 3 months at this scale, gardening becomes not just a hobby, but a community gift. Each plantlet costs you approximately 24 cents in materials. That includes the MS medium, the hormones, the substrate, and your basic supplies. Walk into any garden center and you'll pay $10 to $20 for a single bougainvillea in a pot. Some specialty nurseries charge even more for established plants in bloom. When you multiply 300 plants by that $10 to $20 price range, you're looking at $3,000 to $6,000 worth of plants that cost you less than $75 to produce. The time investment runs 3 months from stem segment to garden-ready plant. That might sound long, but consider the alternative. Traditional cuttings take nearly as long and give you far fewer successful plants. When you're working with large quantities, tissue culture is faster and more reliable. You're not waiting for one cutting to root while watching 3 others fail. You're processing batches where 96% succeed at every stage. One stem segment yields roughly 300 plants within that 3-month cycle when you factor in shoot multiplication and rooting success. This efficiency per unit of time is what makes the method suitable for factory-style production right in your home. A small mother plant can fill an entire neighborhood. You start with one healthy branch, take a few stem segments, and within 3 months you have more bougainvillea than you know what to do with. That's the beauty of exponential multiplication. Here's where the practical side gets exciting. You can fill your own landscape with vibrant color without spending hundreds of dollars at the nursery. You can share plants with friends and family, giving them something that costs you pennies but brings years of beauty. Community gardens always need donations, and your propagated bougainvilleas can transform public spaces. Some of you might even consider starting a small side income, selling plants at local markets or to neighbors who admire your growing skills. The environmental benefits matter too. Bougainvillea tolerates drought better than most flowering plants. Once established, these plants need minimal extra fertilizer and very little irrigation. That conserves water resources in your community and reduces chemical runoff into local waterways. When you propagate drought-tolerant plants, you're making a sustainable choice that benefits everyone. But here's the real magic, and it goes deeper than money or environmental benefits. The pride of growing hundreds of plants from a single cutting stays with you. The joy of giving garden-ready plants to loved ones and watching their faces light up. The satisfaction of mastering a skill that feels almost magical when you first start. These emotional rewards can't be measured in dollars. It's a gift that keeps giving. This process teaches you something valuable. Precision in your methods creates predictable, repeatable success. The same principles work for other plants, other varieties, other goals. Once you understand how to control the conditions and use the right formulas, you hold a skill that applies far beyond Bougainvillea. You've learned the complete method, from selecting new river stem segments to hardening off garden-ready plants. The setup process, preparing those first 1,000 cuttings and getting them into culture, takes about 7 days of focused work. The full journey to a thriving plant ready for your garden is a 12-week labor of love, but the results speak for themselves. Start small with 1 or 2 stem segments. Follow the exact formulas we've shared and watch your confidence grow alongside your plants. Drop a comment below and let me know which variety you're excited to try first. If you found this video helpful, hit that like button and share it with a friend who needs to know about low-maintenance gardening. In just a few months, you could be the gardener in your neighborhood who transforms a single cutting into a cascade of color, sharing the beauty and the knowledge with everyone around you. Remember, my dear friends, that the most satisfying gardens are those we create with our own hands and a little patience.